Welcome to the EdgeSphere tutorial, where we'll show you how our integrated development tool brings your entire Edge AI workflow into one place. From recording sensor data, validating it, preparing datasets, building models, and finally deploying them onto the hardware. In this walkthrough, I'll guide you through all the core features available today, show you how each module works, and help you go from raw data to a running application on the GPX10. Let's get started. This is the EdgeSphere landing page, the home base for everything you'll do with ambient processors. Right in the center, you'll see a visual of the chip surrounded by different sensors and AI components. That pretty much sums up what EdgeSphere is trying to do. Bring the entire Edge AI pipeline into one ecosystem instead of sending you across multiple tools. On the right, you have the name and a short description. EdgeSphere handles data collection, feature engineering, model creation, and deployment. We're rolling out modules gradually, and the ones you see here are the ones ready today. Before moving on, let's take a look at the bottom right corner. Those connection indicators are red right now because no board is plugged in. Once we connect a GPX10 dev board, they'll switch to green. All right, let's head to the next part. Before collecting any data, we need to make sure the board is running the correct firmware. This also gives us a chance to confirm that the hardware, drivers, and flashing pipeline are all working properly. This is the Firmware Upgrade tab. It allows you to flash compiled applications onto the GPX hardware. We will start by flashing the I²S Alexa application as a quick demo and hardware check. After confirming it works, we will flash the EdgeSphere application, which is needed for all upcoming data collection steps. First, upload the binary file for the I²S Alexa demo. We use this application because it quickly confirms the board is detected, JTAG and UART are functioning correctly. The flashing pipeline works end-to-end. The firmware boots and the device responds. Select the correct chip. Ensure both indicators in the bottom right corner are green. Now click Upgrade FW. You will see a live progress bar showing the flashing stages. Once it completes, the Alexa voice demo should start running. When you say Alexa, the inference LED on the board will flash green, indicating the wake word model is responding correctly.
To get started, let's flash the firmware required by EdgeSphere. Upload the EdgeSphere firmware.bin file and again confirm that JTAG and UART are both green. Click Upgrade FW. When the progress bar completes and the confirmation appears, the board is now running the firmware needed for the rest of the tutorial. Now we can move into the data collection pipeline. This section is built for one thing: collecting clean, labeled audio samples straight from the GPX10's onboard I²S microphone. Whether you're working on wake word models, keyword detection, or tiny ML audio tasks, this is where your dataset begins. On the right, you'll see a simple form that keeps your dataset clean and organized. You'll enter the speaker's name, the word or phrase to record, duration of each sample, number of samples, the sampling frequency, which is currently 8 kHz. Fill these fields accurately, and your dataset will remain consistent and ready for training. Before starting, check the bottom right indicators. They should now be green, confirming the board is connected and ready. When you click Start Recording, a few things happen automatically. The animation on the left becomes active. The white ball circles once for each sample duration. The waveform area resets. A countdown prompts the user when to speak. EdgeSphere also adds a short pause between samples so the speaker can reset. After all samples are recorded, EdgeSphere automatically saves every audio clip into a structured dataset folder, generates an Excel sheet with labels, timestamps, device information, and session details. Next, let's move to image collection. This page helps you capture images for vision tasks such as gesture recognition, object classification, or small vision-based ML models. The structure is similar. You enter person name, class name, for example, bottle, cup, hand wave, gesture-1, etc. Below that is the camera selector. EdgeSphere supports the GPX10's onboard HM-EO1B0 camera, your laptop webcam, any external USB webcam. This means you can prototype datasets even if hardware isn't connected. If you choose the GPX camera, ensure the bottom indicators show green. Click Start Streaming to activate the live feed. Position your object.
adjust the lighting, perform the gesture. Whenever you're ready, press the camera icon to capture a frame. You can take as many images as you want until you stop the stream manually. All captured images are automatically saved into a structured folder. Show camera demo result log. Now let's open the result log. This is where your audio collection outputs end up. Think of it as your data inbox. Each entry shows the file name, the last modified time. On the right, you'll see options to download to save the Excel sheet, delete to remove a log, transcribe, the most powerful feature here, transcription. Transcription helps fix real-world recording mistakes. Maybe someone said the wrong word. Maybe they mumbled. Maybe there was background noise. EdgeSphere can automatically verify and correct labels using a language model. You can choose between small, medium, or large models. Small is fastest, and large is the most accurate. Once transcription is done, the Excel sheet updates with corrected labels. Every row also includes a clickable audio hyperlink. You can listen to each sample directly from the sheet. This makes dataset cleaning simple and efficient. And that brings us to the end of the EdgeSphere walkthrough. You've now seen the complete workflow: flashing firmware, collecting audio and image data, validating datasets, transcribing samples, and preparing everything for downstream AI workflows. EdgeSphere keeps the entire process unified, so you never have to jump between tools or manage scattered scripts. Whether you're experimenting with tiny ML ideas or deploying full Edge AI applications, EdgeSphere is built to make your development faster, cleaner, and smoother. In the next video, we'll run through a live example where we'll show you how to modify the Alexa wake word application to detect any word or sound of your choice. We're excited for you to explore what's possible with EdgeSphere and build your own on-device intelligence.